Okay, continuing on from where we left off in the previous video, I want to look at going through the other half of this first section of probability theory and just some more examples here. This is another example where it says refer to the sample space where we flipped a coin 3 times and find the probability of each event below. Now, if you remember from back up earlier, it was a few pages ago, we actually listed out the entire sample space right here for flipping a coin 3 times right here. So we had 8 different possibilities that we were looking at as far as those problems go. So this first part wants us to say we flip a coin 3 times and we get all tails. So let's do probability for A, probability of all tails when you flip a coin 3 times. I didn't put that part about the 3 times, but we're just assuming we are flipping a coin 3 times. It is good to have more detail, but I'm being brief for the sake of time. Now, when we flip the coin, we know there's 8 total possible options to have happen. Now, how many of those end up being all tails when you look at it? Well, if you go back up above, you'll see that it was 1 time out of the 8 total possibilities. So over here on your sample space, we have 1 time that it was all tails out of 8 possible options. So our answer is going to be 1 out of 8 as our solution. Okay. Next, it says we flip a coin 3 times and we get exactly 1 head. So probability of exactly 1H, when we flip a coin 3 times. Well, we know there's 8 total possible options, but we want 1H to happen, exactly 1H. So when you go up here, how many times did 1H happen? Well, I can see that I have 1H right here in this option, 1H right here in this option, and 1H right here in this option. Now, every other spot has more than 1H, or it has no H's. So exactly 1H will be those 3 options right there out of 8 total possibilities. So 3 out of 8. And while we're talking about probabilities, it is definitely important to notice something about probabilities. Go down here to the section labeled probability limits. And it's important to remember that probabilities are always going to be expressed as a fraction. So we've seen them most time as a fraction already. But they can also be a decimal number. Whenever we did that flight problem with the passengers getting bumped, we ended up having like a decimal answer. It wasn't like a pretty decimal answer. It had that scientific notation stuff. But that they're either going to be a fraction or a decimal number, and they can be represented as a fraction or decimal between the numbers 1 and 0. Now, you have something called an impossible event. So if an event is impossible to happen, it's going to be on the lower end, the lower extreme. It's going to have a 0 probability, which is 0% chance of happening. And the example that I have here is getting 5 aces from a standard deck of 52 cards. Well, you can't draw 5 aces because there's only 4 aces to begin with. So it's impossible to draw 5. That has a 0% chance or a 0 probability to happen. Now, there is an event that's certain to occur as well, or there's a probability for an event that is certain. That's always going to be equal to 1, or if you're doing the percent, 100%, 1 and 100% are the same number. So when randomly selecting a day of the week, you get a day containing the letter Y. That is a 100% chance, or 1 probability if you're using the decimal number. Okay. So for any event other than certain and impossible, any other probability or any other event's probability is going to be between 0 and 1, including 0 and 1. Okay. So there's an example in the homework where they say, okay, here's a bunch of values. Tell which one cannot be a probability. So we want to just circle the ones that cannot be probabilities. And if you look through here, there's a few that stand out. Now, if you look at 2 over 5, that's going to end up being 0.4 right there. So that's that's going to be fine to have as a probability, not a big deal. Square root of 2, you can actually do that on your calculator if you want to use your calculator to figure out what that is. The square root button is above x. It's x2. It's the blue square root button above x2, and you just put the 2 underneath, and gives you 1.41 roughly if you do decimal places. Well, that definitely cannot be a probability because that is over 1. So it has a value over 1. It can't be a probability. Now, 1, the value 1 is okay because it's a certain event. It's definitely going to happen. So it's definitely okay. Now, negative 4.3 is bad because it itself is below 0. So you can't have probabilities that are lower than 0. The 0 is the lowest. Okay. Also, look at 5 over 3. You may not know what it is as a decimal. You can do 5 divided by 3 if you want to see the decimal version. It ends up being 1.6, like this, which is over 1 as well. Okay. We definitely know that's not going to be a probability. And whenever you see fractions, if you have the numerator being larger than the denominator, it's always going to end up being over 1. So none of those are ever going to be possible for a probability. And if you ever have a homework problem where you're putting the numerator being larger than the denominator, that should be a red flag for you because that can't happen. Now 0 is okay actually because 0 is your impossible event, so it's definitely all right. And 0.072, it is a really small probability, like it's 7.2% chance, but it's okay. It's just a little bit past 0. It's between 0 and 1, so it's all right. Now, the last one right here is actually odds notation. Odds has this, it's 3 to 1 is how you would read this. Odds notation is a little bit different from probability. So odds isn't probability. You could actually make it into probability if you needed to. It'd be 3/4 as a fraction, but it is different. It's a different concept from probability itself. It's connected, but not exactly the same. Okay. Going down here, one other thing we want to talk about just briefly is the terminology we use. And we use the word unlikely and unusual quite a bit. In this chapter especially, unlikely is coming up quite a bit more. Now, an event is said to be unlikely if its probability is very, very small. So basically it has a small chance to happen, such as 5% or less is generally a good gauge for if something is going to be unlikely or not. Okay, does it have a 5% chance or not? Now, on the other hand, an event is said to have an unusual number of outcomes, or we used in the past chapters a significant number of outcomes if that number is very far from what you would typically expect to have happen. Right there. So we used, value, like if your outcome was more than 2 standard deviations away from the mean, that was classified as a kind of an unusual scenario, like outliers end up being unusual. Okay, we can even look at these events that happen in this chapter as like, are they something we would expect to happen? Like, are they unusual or not? Okay, look at this example below where we have a fair coin tossed 1,000 times. Okay, probably you would want to use a simulator for this. It says the probability of getting 500 heads in 1,000 tosses, and this is getting exactly 500 heads right here. Okay, exactly 500 heads in 1,000 tosses is 0.0252. Now you definitely need some kind of technology to calculate that probability, and we'll show you like later on in chapter 5 actually how you can do that with a calculator. But it asks 2 questions here. First it says, is this result unlikely? And then other question is, are 500 heads an unusual number of outcomes to expect? Well, since the probability is 0.0252, this is actually going to be unlikely. So this is very unlikely to happen. So this is unlikely since the probability of that happening is less than 5%. A good number to use is 5%. But if we think about 500 heads, is 500 heads an unusual expectation? Well, not really. I mean, Normally, if we flip a coin 1,000 times, we expect about half of the heads to, half of the coins to be heads. 500 is exactly half, actually. Now, it might be, weird to get exactly that number right there. It might be unusual from the sense of like, oh, wow, how did we get exactly half? But normally we expect about half of them to be heads. So this result is not, I'm going to say not an unusual. So it's not an unusual number of successes since we normally expect about half to be heads anyway. But yeah. So unlikely and unusual used quite a bit. Unlikely you'll see it a lot more in this chapter because we do talk about the likelihood of things in terms of probability. So definitely a change of pace from stuff we've done in the past. Now the last thing I will look at is probability tables. And these are probably my favorite types of problems because you have to kind of be on your feet when you're looking at these tables. And one thing about these tables is you have to read them two different directions. So you can see that like this polygraph, this is basically lie detector test. It has two ways you read it. So you go up and down when you read it like this. So you have, if you're looking at that first column, the no column, which it says did not lie. Whenever these people took the test, they didn't tell a lie. So we have 12 plus 30 that did not lie. So we have 42 people that basically told the truth when they went and took the machine. Whereas 43 people lied when they went and asked a question on the machine. Now, what about left and right, reading it across? Well, if you look here in this first column right here, or the first row, you have 12 and 37 people in that. So 49 people. Well, 49 people had a positive result. So what's happening here with these 49 people? Positive. Positive means that the machine buzzed whenever they were asked a question. So what does that mean happen? Like, what does the machine think is going on with these 49 people? And what's happening with these is the machine thinks they're lying. So the machine thinks lie. And then negative test result, those are going to be people the machine didn't react to. So those people, the machine thinks that 36 people, 30 and 6, are telling the truth. So the machine thinks. Now let's think about what the numbers in each section kind of represent. Like if you look over here at these 37. So in this very, very top right corner, we have 37 people. Those are the people who lied and the machine was positive test. So those 37 people lied and the machine also thought they lied. Okay? So those people right there are, valid. That's what you would expect. They lied and the machine also said they lied. So the results kind of match. There is, though, these 12 people beside those 37. And what is actually going on with those people? Okay? Well, those 12 people didn't lie. So, those 12 people told the truth. But what happened when they took the machine or they were hooked up to the machine? The machine actually thought it was a lie. So this is actually what we call a false positive. Because the lie detector detected a lie when they actually told the truth. And that's actually an error, like a type of error. It's our type 1 error, actually, where, if you have that value being too high, you probably have to recalibrate your machine or do something different, like maybe use a different machine. Okay? You can't have that number being too high. And then going to another place on this table. Okay? So the 30 underneath the 12, those are the people that, told the truth, and the machine also said they told the truth. So those 30 people are definitely okay. The 37 and the 30, those people are definitely fine. But what about these 6 people right here in the bottom right corner? What's going on with those people? Well, those people right there, when they took the machine, they lied to the machine, but the machine thought it was the truth. So it didn't catch their lie. And this is actually what we call a false negative. And you can think about the repercussions of some type of error like this, okay? Maybe they're asking them questions about an incident that happened, and if they lie or whatever, and the machine didn't pick it up, it thought it was the truth, maybe those criminals right there can get free. Like they, bypassed the machine. They got lucky, I guess you can say. So, you can think about the repercussions of this type of error. If it is too large, you probably have to recalibrate your machine so that the value is much smaller. Okay, you want it to be as accurate as possible. Okay, but anyway, that's the important thing about reading these tables, is like making sure you know what each cell is saying when you look at the problems. Now, looking down here at this A part, B part, and C part, it says how many responses are summarized in this table. All you have to do is just add up all the different numbers in the cells. So how many different people are represented? There's 85 total people that are in the table. Okay, and then it says how many times did the polygraph provide negative test? Well, you can look at the negative test. It's a cross. You have to read kind of across for negative test. So 30 and 6 gave negative. So 36 people total had a negative response. And then, if a response is randomly selected, find the probability of it being a negative test. So I want to do probability of negative test. And remember, you're always making a fraction when you do probability. So we want to do the number of negatives on top over the total number on bottom. Okay. Well, we have 36 negatives over 85 total. And you can calculate that with the calculator. Get you a good little decimal number. Maybe 3 or 4 decimal places is enough. So we get 0.42, maybe 4, which is a 42.4% chance of negative. Now you should be able to do the problems with section 4.1.